Hey guys, welcome to my channel. I'm Jenny Carter, and today we have a pretty interesting topic, guys. So I'm gonna be going over breadth first search, right? You know what I'm saying, or BFS for short, guys. So this is guys, last time we talked about depth first search. So if you guys haven't seen that video, please go check that out. And we know that the depth first search, right, prioritizes going deep into a path as much as possible, right? And then backtrack and then visit other paths, right? But breadth first search, right, you know, it's a little bit different, right? This one word prioritizes breadth, right? I'm saying the width, pretty much, right? You know, it does things layer by layer, right? We traverse things level by level. So the same way we do it for tree problems, right? We've done a lot of tree problems on this channel, so we're pretty comfortable with breadth first search, right? But this we're going to be doing the same thing, guys, as we do on the trees, guys. You know, the only difference, we're going to be using this addition of the instruction, right? It's going to be useful and letting us know, right, if we visited a node now, right? Because there may be cycles in the graph, right? So to account for that, right, we need a structure that can tell us, right? So we can use a set, or we can use a Boolean array, right? That pretty much can let us know if a node has already been visited, right? So that's exactly what we're going to do. So last time we went we talked about, you know, we did a walkthrough, right? And then we went to the code implementation, right? So we're going to do the same format here, right? Keep it consistent. So we're going to do this example that I have here on the iPad right there. And then, yeah. So let's get started, guys. So before we get started, guys, know if you guys are new here, consider subscribing to the channel, guys, because we do a lot of data structures and algorithm problems on this channel, right? So especially make sure that you like this content so that you know it can really help me out. We really appreciate that a lot, guys. So let's get into the video. Okay, so right now we have a so we can start off with any node, guys, what I'm saying. So to keep it kind of simple, I'm saying, for simplicity, we're gonna choose the node 0, right? So, and then we know that for a depth first search, right, we use a stack, right? You know, like the recursive call stack, whatever I'm saying, we use a stack, right? That's the behavior, right? This time we're gonna be using a queue, guys, you know, because we know that, you know, we want these things level by level, guys. So that's the way that it normally works, what I'm saying. So always know depth first search stack, right? Recursive stack, whatever. Breadth first search queue, right? I'm saying the same way we do it for the tree problem, right? So same thing. So pretty much, guys. So yeah, we're gonna pull stuff from the front, right? So yeah. So the way we're gonna do it, guys, know. So now we're gonna start off with 0, right? We're gonna start off 0. So 0 gets added to the queue, right? I'm saying, and there are no more nodes, so 0 is the initial node, right? So we're gonna visit 0 now, right? So 0 gets visited, right? So the current node is 0, and then we take 0 out of the queue, right? And then we're gonna print 0, guys, what I'm saying. Same way we did it for the other one, print 0, right? And then make sure that we also add 0 to the set, right? To show us that we visited that node, right? So we add 0 to the set, guys, right? And what's next, guys? So now 0 is going to add out of its neighbors, what I'm saying. So there are 2 neighbors, right? 1 and 2, right? So we add 1, and then we add 2, right? I'm saying. Guys, see those 2 neighbors that we have here? That's the way I did it, right? So from 0, we got 1 and 2 as the neighbors, right? I'm saying. So 1 and 2 gets added, right? I'm saying. And then, yeah. So now, we added 1, we added 2, right? So now so we know that the queue is first in, first out, right? Unlike the stack, which is last in, first out. You know what I'm saying. So yeah, so now we've processed 0, right? We printed 0, and then we added all of its neighbors, right? So now we're done, pretty much. There's nothing else to do. So now we go on to the next node, right? The next eligible node is gonna be 1, right? I'm saying, because we're pulling from the front, I'm saying, right? So now 1's gonna get popped off this, taken off the queue, right? I'm saying we take 1 out, and then the current node that we're on right now is 1, right? I'm saying we're right here, right? Well, we're at 1 right now. Okay. Pen's not working. Okay. Okay. So now we're at 1, right? So now we're gonna add 1 to the set, and then we also print 1, guys, right? Make sure that we print them, right? You know what I'm saying. That's the processing that we're doing. We're printing. So we're doing something simple. I'm saying just like we did in the depth first search, right? So now one is gonna visit all of its neighbors as well, right? So we could see the neighbors of one, right? Is 1, 2, and 3, right? So we're gonna pretty much add them to the queue, guys, right? That's exactly what we're gonna do. So we're gonna add 0 to the queue. We're gonna add 2 to the queue, and we're gonna add 3 to the queue, guys, right? They all get added, you know what I'm saying? Okay. Just move them forward a little bit, you know what I'm saying? So now we're done processing one, right? So now we can go on to the next eligible node, right? So we now two, right? We check two is not in the set, right? So we can visit 2, you know what I'm saying? Yeah, so I should have showed you guys the same thing for 1 and 0, but you know what I'm saying? We know it by now, right? What it sets for. So set, so 2 is not in the set, right? You know what I'm saying? 2 is not in the set, so we can visit 2, you know what I'm saying? So we add 2 to the set, right? Should I get that away? We add 2 to the set, right? And then we print 2 as well, right? We print 2 right there, right? 2 gets printed. And then what's next, guys? No, the next thing that we do, we visit all of 2's neighbors, right? Right? So 2 has 0, right? 0, 1, and 3, right? Because right here, guys, what I'm saying 0, 1, and 3 as neighbors, right? So now we're done. So now yeah, we go on to the next node that's eligible, right? I'm saying so now we visit 0, right? I'm saying so current node 0. So we see that 0 is already in the set, right? So we're not gonna visit 0 again, right? So you skip this one, right? 0 has already been visited already, so we do. That's why we need the set to let us know that, right? So the set, so set 0 has already been visited, so skip 0, right? So now we go to 2, right? 2, I'm saying 2 has already been visited. 2 already been visited, so we skip it, right? And then now the next node that's eligible, right, is 3. I'm saying so 3 it gets I'm saying 3 is the next eligible, so we make sure I add 3. So now we're gonna visit 3, right? So we add 3 to the set, and then we also print 3, guys, what I'm saying, to make sure that we do that. I'm saying very, very important. And then yeah, should I pop 3 up the stack, right? And then 3 is gonna also add, make sure that I move those forward a little bit. So now 3 is gonna add its neighbors as well, right? So we need to add 1 and 2, right? I'm saying 1 and 2, right? They both get added to the queue, right? And then yeah, so we're done with 3. So now we take the next node, which is 0, right? And then 0 already in the set, so we don't visit it again, right? We go on to the next one, which is 1, right? 1 has already been visited, so don't worry about it. So the next one is 3, right? What's 3, right? And then now current node is 3. 3 has already been visited, so I gotta visit again, right? And then the next node that should be eligible, right? 1, right? 1 already been visited, so we skip it. And then 2, right? 2 has already been visited, so we don't visit it again, right? So we skip, and the queue is empty, so we would exit out the loop, right? And then just like that, guys, we were successfully able to print the breadth first search traversal of this graph, guys. So report, right? So you can see that we do things layer by layer, right? So we get the first layer, right, which is the source node, right? And then we got the other layer, I'm saying, which includes 1 and 2, right? Which is the layer called it to 1 distance away from 0. I'm saying from the source node, right? I'm saying, and then we had this other layer, right? That's a layer by itself, which is I'm saying, which is 2 distance away from 0 from the source node, right? You know what I'm saying? So yeah, so breadth first search algorithms are very efficient, right? Especially for finding like the shortest path, right? On a graph, or I'm saying, we can use breadth first search, especially when the weight of the edges, right, are all the same or equal. I'm saying, we use breadth first search, guys. So you can see it's a very efficient way of doing things level by level. That's why we do a 0. I'm saying 0. We do 0 first, right? And then we do 1 and 2, right? Which is the next 2 because they're in the same level. I'm saying, and then we do 3, guys. So yeah. So right now we're gonna jump into the code quickly. Okay. Yeah, guys. So we have a breadth first search function, right? So which takes in an array to the array of edges, right? I'm saying, so array of edges, right? So so we'll build the graph, right, in agency list format. I'm saying, I've done a video on this. If you guys don't know what I'm talking about, highly suggest you guys go check it out. There is a cool way to represent the graphs, guys, and to do manipulation, right? So for every u of v, right, I'm saying, we have u pointing to v and then v pointing to u, guys. What I'm saying, so we have that, right? And then yeah, because we have an undirected graph, guys, right? You can see, right? There's no arrows. What I'm saying, so for every u v, right, we got v pointing back to u, right? So that's why we have that, right? So let's get back to the screen. All right, so we have that here, right? So now we add 0 to the queue. I'm saying, so we start off with the source node. I'm saying, it could be whatever node you want it to be. I'm saying, we're just doing 0 for simplicity, right? Then we have a set, and then we have while the queue is not empty, right, we process the nodes, right? If we've already seen the node, we continue, we skip it, just like the other one, guys. I'm saying, then we add the node to the set, and then we print it, and then we visit all of its neighbors, guys. So it's as easy as that, guys. So yeah, so you see that we have 0, 1, 2, 3, right? I'm saying, which is exactly what we found, right? Which was 0, 1, 2, and 3, guys. So could you see that? Because we do things layer by layer, so a little bit different. I'm saying, yeah. Let's go back to that screen. All right, cool. So hopefully that kind of made sense, guys, and you guys understand what I'm talking about. Hopefully you guys can yeah, because we're gonna be doing using breadth first search and depth first search and a lot of graph problems here on this channel. So consider subscribing if that's something that you're interested in, right? So yeah, thank you guys for watching, and I'll see you guys in the next video.